Hello, my name is Jacob Doyle, and my urban theory for this semester was Metacity Data Town. The idea of Metacity is using all of the Earth's surface that can be turned into a city. And so the Earth has a surface area of 544,552,000 kilometers squared. After you subtract the oceans, you're at 205,770,000 kilometers. But after you subtract ideas like the grain boundary, mountain ranges, seismic faults, deserts, and forests, you're at 60,126,701 kilometers squared that can possibly be used for city development. As you can see in the image above, you're looking at all the possible regions that can be turned into a city. Now, Data Town is the concept of using a 40 kilometer by 40 kilometer block and completely disregarding any concept of topography, culture, society construct, and just building one design within the whole area that can house 241 million people into it. Now, from the image, you can see that it's broken up into a different series of portions, and the sectors, all at their percentage, you have a CO2 forest covering 7.4%, agriculture covering 55.4%, the airport having less than 1%, as well as the allotment gardens and the cemetery. Construction area having 0.3%, daytime recreation having 0.3%, dry nature 2.1%, greenhouses 0.3%, industrial areas 0.3%, living areas 5.1%, molated roads at 2.6%, nocturnal recreation at 0.4%, other constructs not within the scope at 10.1%, parks at 0.4%, public transportation at 0.3%, recreational water at 0.1%, scrap yards at 0.1%, services at 0.2%, sports at 0.6%, surface water at 11.9%, unmetaled roads at 0.3%, waste dumps at 0.1, water reservoir at zero point 0, and wet nature at 1.4%. This, however, does not properly represent the amount of usable square footage this construct has. In many places, you are looking at developments that are going multiple stories high. So most often the residential units are looking at 10 plus stories. Energy development centers are looking at 760 meters tall of wind production. CO2 forests are looking at a 10 to 100 story construction based off of the CO2 consumption methods that they use. Agriculture even taller at a possible 100 floors, and really desperately needing it, making up all of the different farming agricultural uses that are desired for the modern day living, as well as the amount of waste that's going to build up at so many meters tall. It really does create an entire skyline as well as the plan. As I previously mentioned, living being at 5.1% of the actual layout of it, you also have multiple story construction of housing and its connected gardens that allotment. These gardens and housing are designed to be able to support the recreational personal uses that you would have, such as a backyard or a front yard, as well as having your own personal property to do whatever you want with this kind of outdoor area. Most of the times you're looking at a even split of 50-50. However, depending on cost function, that can be switched, often heavily enforcing the amount of outdoor area preferred over the indoor area, just because that is more what we are used to for recreation. And if you're disregarding weather, you can supply more of an outdoor lifestyle than you can an indoor lifestyle. Just to also show you some of the types of images of what you would have in your skyline, here's the CO2 farm raising high above any city construction, and some of the views into the natural forests that you would have just to consume some of the CO2 or to develop in the agricultural center for nuts and berries. The 40 by 40 kilometer design of Datatown is based off of the ability to get from one side of the town to the other using the bullet train. That's why they chose the distance they did, was because it was achievable in one day around the different sectors of the city design. Now, that 40 by 40 block does start to take up a lot of space within the 60 million kilometers that you have based off of Metacity. From there, you start looking at the fact that Datatown cannot support its own amount of waste if you start including or discluding the factor of recycling. From there, you're looking at a construct that's growing faster and faster, with a population that's growing faster and faster, in a allotment of land that's growing smaller and smaller over time, becoming more and more unstable. Now, looking at that amount of waste, you do have a large enough footprint where you can develop over time, but you can see from the image, if you end up using one tower, they're going to grow fairly fast. If you just choose to disperse them between multiple towers, yeah, you'll have multiple hills growing fast, but shown in the picture, you've got about 150 years until that whole area is filled, and that's not going to be sustainable with that height of growth. Things are going to expand out or spill over into the other area, of which next door happens to be in the plan the livable area. In total, I find a theory like this to be really interesting due to the fact that other theories can be applied on top of this, where they don't address anything based off of design, psychology, street level interaction. This is just the bare minimum of what you can do with it, which lends itself really freely to be a part of a larger context of design, but giving itself a strong fact based baseline that you can actually design something off of. I mean, from here, we already have a plan of how things are going to work out, how certain areas are already related to each other based off of proximity, and how much effort it takes to move things from one place to another. So, from there, those parameters start framing out a larger social context as well as debate on what does the form look like in the end, where do things sit in proximity, and how do they face each other, what relationships and possible future social importances are going to take place based off of the skyline and the street level that you're going to form in these different areas. In conclusion, this is a really baseline design, like I just said, but it is something that is a framing tool for the potential future. Now, for a species that's definitely becoming fully urbanized, where we are used to an entire digital age, and this theory did not discuss anything about the digital age, it is applicable in this sense where you are looking at different cities, not one holistic city around the whole world, but a series of them, having planned for an airport, mass transit systems. But I do want to question how this relates to one each other. What do the different cities look like in relationship to each other? Can you see one? And the spaces that are left in between one another, how does those become addressed? Where are we placing the importance of viewshed? As you can see in the image, I mean, you're looking at some giant mounds of trash, one of the highest constructs in the city over a period of so many years. Is that what we use to identify from one area to another, is mounds of trash? Or do we find other ways to address this? I think it also becomes interesting when you start challenging the ideas of interplanetary travel as well as, I mean, in atmosphere travel through the air. We are definitely building up in a design like this that's going hundreds of kilometers into the air in some instances, which really threatens the amount of atmospheric occupiable area we have at this point, looking at mega structures soaring through everything. So I'll leave you guys with those thoughts, and thank you for listening to my presentation. Thanks.